We have an example problem here. The speed of an ultrasonic sound of frequency 45 kilohertz in air is 352 meters per second. What is the air temperature? So we've been given frequency, we've been given the speed of this sound. All right, we want the temperature. The only equation we have at this point in time is the speed of sound in air is 331 meters per second times the square root of the temperature in degrees Celsius plus 273 over 273. So all of this in the numerator there divided by 273. So we can find this temperature because we are given the speed of the sound. Turns out we don't actually need the frequency. We would use the frequency to find wavelength if we wanted to know the wavelength, because we know the speed of a wave is wavelength times frequency. Knowing the speed and the frequency, we could find wavelength. Now again, this equation is assuming dry air at sea level, but that's fine. That's what we need to assume. So I'm going to go ahead and put in my 352. I know I'm going to go ahead also and divide by the 331. Both of these are in meters per second. So those units are going to cancel. That leaves me with the square root of this temperature in degrees Celsius. All of that good stuff. To get rid of this square root, I'll go ahead and square both sides. So this ratio of 352 over 331 squared will equal the temperature, well, everything that was under the square root. So if I multiply the 273 to the left side and then subtract this 273, this is going to give us our temperature. So 273 times this ratio, this will give us the temperature of the air. Again, assuming the air, it's dry, so very little humidity and at sea level. All right, I'm coming up with, oops, not that. 35.74. This is in degrees Celsius, but unit-wise, we should only have the 2 sig figs. So 36 degrees Celsius would be the air temperature in this particular case.